Okay, so today we are going to look at volumes of cones. So, how do we deal with volume of cone? Well, we got a formula here. We really have one, though it looks like we have two. So, if you think about the other conic sections that you have done, so the cylinder, um, what other ones have we done? You've done a cylinder, you've done a prism. One of the big things you do is you take the base and you multiply it by the height. That's always been part of it. So now what we have is again, we're going to be finding the base of something. We're going to be multiplying by the height, but because that base, right? Because it only has that one base, it ends up in being a point. We then multiply that whole thing by 1/3. So in other words, we're going to take the base, multiply by the height, times 1/3. The base, though, how do we find the base? Well, the base in this case is a circle. So this piece right here, right, is representing the area of the base. And then we're just multiplying it by the height times 1/3. Okay, so that's our formula. How do we go and use it? Well, let's go and do it. So in order to, let's see what we got here. Let's go and identify some different pieces of this. So what are some things we need to know in order to fill out our formula? So let's just put our formula. I'm going to go and grab it right here. I'm going to copy it. And let's figure out the pieces that we need. Obviously, we're trying to find the volume, so that's not going to happen right now. But the things that we need to know in this case, we need to know specifically what is, actually, let me do this in a darker color. Let's do this purple. What is R and what is H? So notice in this case, and I'm going to just kind of point this out because of book notation, when they take, in this case, and they take the arrow and they point it to the center like this, kind of to the center of that circle, that's representing a diameter. So that 6 centimeters is the diameter of that circle, which means the radius is half of that, or 3. And the height is specifically given as 7. Super convenient. So let's put it all together into our formula. So we get the volume of the cone equals 1/3 pi r squared. R in this case is 3, so 3 squared times 7. And we are going to then go and clean this up. So we get the volume equals 9 times 7 is 63. So 63 divided by 3 pi, which ends up being 21 pi. Now let's put our units. This is a volume, right? So this is going to be cubes because it's dimension times dimension times dimension, right? Height times the area the area of the circle, which is area squared units. So again, just kind of note, volume's always cubed, right? So in this case, centimeters cubed. Okay, let's look at another example. Let's look at this one. So this one's a little bit different in that, well, first off, let's go through what we know. So again, let's go back to oops, this thing crashed a little bit. Let's see if we can come back to it real quick and get back in. Okay, little crash there, but we're okay. So let's see what we can do here. I'm going to go and grab this formula again because it is super useful. It's the one we are using today. Okay, from here, what do we want to do? So what I'm going to do here is I need to figure out what is R, what is H again. In this case, we don't know what H is, right? H is this height right here, but they didn't give it to us. They gave us what's called the slant height. That 10 is representing the slant height because that is the distance from here to here. That's a diagonal height. We don't want that. So that's not so directly helpful. But let's see what we got. So I think you'd agree that the radius, since the diameter is 12, the radius has to be 6. Let's go figure out the height. Well, if we want to go figure out the height, right, we have a triangle. Let's just kind of pull that triangle out for a second. We have a triangle that looks like this. Specifically, it's a right triangle, super convenient, as always. And we have the hypotenuse being 10. We don't know what h is, but we also have the radius being 6, right? So we have two sides of a triangle. We can use Pythagoras theorem in order to find a third. So in other words, I can say h squared plus 6 squared equals 10 squared. So h squared equals, and I'm just going to do the math. So 10 squared is 100 minus 6 squared, which is 36. So h squared is 64, meaning that h equals plus or minus 8. But of course, we're talking about the height of something, some physical object. So h equals 8. Perfect. Now we have everything we need to continue. So let's plug everything into our formula. So we get the volume equals 1/3 pi 6 squared times 8. So doing that math, what do we get? So 6 squared is 36. 36 divided by 3 is 12. 12 times 8 is 96. So volume equals 96 pi. And again, our units are, since this is in inches, this is a volume, this is inches cubed. Let's go on in my deep radio voice. Okay, what do we got here? So the figure represents a conical cone. So I didn't give us any measures here. So let's see. I'm going to quickly draw a cone here. So you get to watch me draw a cone. Let's see if I can do that. So the cone's going to look something like this. So the figure represents a conical cone. How many fluid ounces of water can the cone hold? So the information that we are given, we're given that the diameter in this case is going to be, so the diameter is going to be 2.2 inches, and then the slant height, just like on the last one, right? That slant height is going to be 1.8 inches. Reminder, that's that kind of, we're talking about this stuff right here. So just like before, we have a couple things we need to find. One, we need to know what is h, and two, we need to know what is the radius. Now, this is a two-part process, right? We should be able to, at this point, this is very similar to the one we just did, right? We have a slant height, we have a radius, we can go through and find the volume of this. The only thing that's a little tricky here, the only thing that's a little bit different is we got to convert it to ounces. So let's see. Let's do phase one. Phase one, let's go find the volume in terms of inches cubed. So radius is half the diameter, or 1.1 inches. Height, going to use Pythagoras theorem again. So I'm just going to do that underneath the cone. So I'm going to say h squared plus 1.1 squared equals 1.8 squared. So in this case, solving this, I get h squared plus, let's do 1.21 equals 3.24. So h is going to be equal to, when I solve this, right after I've kind of cleaned this up, I'm going to, h is going to be equal to, well, let's do h squared. H squared is going to be equal to 1 plus or, excuse me. I'm showing an extra step here just not to leave anybody out. So h squared equals 2.03, which means h equals plus or minus 1.42. And of course, we want the positive value. So I'm going to say h equals 1.42 inches. Okay, let's go find the volume of this cone. So the volume is going to be equal to, volume equals 1/3 pi r squared. So r in this case is 1.1 squared times h, which is 1.42. So in this case, doing the math, pulling out my calculator, I'm going to get the volume is approximately equal to, so it comes out to 1.799. I'm just going to round this to the nearest tenth. So I'm going to get the volume is approximately 1.80. And our units are, I think you'd agree, inches cubed. But that's not what it's asking for. It's not asking what is it in inches cubed. It wants to know it is in fluid ounces. So reminder how we convert. So they gave us earlier, they gave us this piece, our conversion. So what I'm gonna say, I'm gonna set up a ratio. I'm gonna say 1 inch cubed is to 0.554 fluid ounces as, so since it's inches on top, fluid ounces on the bottom, I'm going to stick to that format. So we know there's 1.80, I guess, inches cubed was the volume of the cone, and we need to know how many fluid ounces. So X fluid ounces. Doing the cross product, right? We can then go and do the cross product. So I get, let's see. Well, I know we have all these units, and I'm going to keep the units just for, you know, consistency's sake, but they are kind of a little bit confusing. But let's do it. So let's do the cross product here. So I'm going to take these two, multiply them together, then I'll take these two and multiply them together, put them on the other side. So 1 times X fluid ounces, so we get 1 inch, so, or 1 times X is X, so this is X inches cubed fluid times fluid ounces. I know that's a little bit awkward, and again, it's just a units thing. We're going to get some canceling out. It's not a huge deal, but that's fine. Let's keep it going. And then I'm going to take 0.554 times 1.8 and multiply the units together. So let's see, 0.554. So I get 0.9972. That doesn't look like a 7. Let's make that look a little bit more like a 7. So 0.9972, and again, it's inches cubed times fluid ounces. Now notice, like I said, those numbers weren't so super important, those units, because look what's going to happen here. I've got inches cubed fluid ounces on one side, inches cubed fluid ounces on the other side. They both cancel out, right? So we get X to be, I'm going to say approximately, right? Because it really wasn't equal to, it was approximately, and I'm going to actually round 0.9972 rounds to 1.0, okay? So X, and just make sure we notice, this X is going to go here. So what is it? It is 1 fluid ounce. Okay? So it represents X equals 1.0 fluid ounces. Okay, last one. We're going to deal with a composite figure. Okay, so the key here with composite figures. A composite figure, as you've seen already, is where you take several shapes and you add them together, right? Or subtract them. So for example, in this case, I'm going to be adding them because I have a cone on top of a cylinder. But it could have been that the cone was inside and I would have had to subtract. But in this case, I want to add. So here is going to be my strategy. And this is my strategy always, okay? And so my strategy always is going to be the following. I'm going to find the volume of both pieces separately, and then I'm going to add them together. So let's see what we got. I'm going to start with the cone for no particular reason. So again, the volume of a cone, right? That's going to be volume equals 1/3 pi r squared h. So in this case, let's see what we know. We know, I'm just going to write down what we know. We know R is, well, if the diameter is 16 millimeters, then R is 8 millimeters. The height, I think you'd agree, the height is going to be this distance from here to here. Since we know that from top to bottom of this composite is 32, we know that the height of the cylinder is 19. 32 minus 19 is 13. So the height is 13 millimeters. Not meters, millimeters. So let's go find the volume of the cone. The volume of the cone is going to be 1/3 pi 8 squared times, not h. H is 13. From there, we can clean it up. So I'm just going to keep this as a fraction. So I get 832 over 3 pi. That represents the volume of the cone. But let's go find the volume of the cylinder. So cylinder. In this case, right? So let's think. In order to find the volume of a cylinder, we need its base times height. So the base is just the area of a circle. So we're going to say, so let's see. Again, the radius is 8. That hasn't changed. The height in this case is 19. So the volume of a cylinder is going to be the base, which is pi r squared, times the height, h. So plugging those values in, we get volume equals pi 8 squared times 19, which is going to be equal to 1216 pi. Okay, so now what do I have? I have the volume of the cylinder, I have the volume of the cone, and what am I going to do? I'm going to add those two pieces together to find the total composite volume. So the total is going to be, so I'm just going to write down total here, is going to be 832 over 3 pi plus 1216 pi. And cleaning that up, I get, if I want to turn this into one fraction, I get 4,480 over 3 pi. And our units are, since this is millimeters, it's millimeters cubed. That's how we deal with composites. I'm going to just point out one little thing before I end this video, just because it tends to be a little bit harder. So let's say in this case, right? Let's say in this case, our figure was a little bit different. So all the measurements are basically the same, but let's say in this case, we had our cylinder, right? So here's my cylinder. And instead of the cone being on top, the cone was inside. So it kind of looks like this. I know the drawing looks a little different. And the measurements are going to be a little bit different, but let's just kind of talk about what have happened. So if they could have asked a couple different things here, right? Usually what they would say is, what is the volume of like everything that's not the cone, right? So all that stuff that, you could, I don't know what that would be, but the stuff surrounding the cone. And the way we would do that, just to be clear, is we would go and find the volume of the cylinder, right? Which, assuming that the things are the same, so if this is 19 and this is, again, what was this? That was 16 here, so the radius is 8, right? So that's 16. So our cylinder would be exactly what we already found, this stuff right here. Now let's take the cone, right? So the cone's going to be a little bit different in this situation. The only thing different, I think you'd agree, whoops, didn't mean to do that. Let's just erase. So the radius of the cone hasn't changed, but the height in this case is, I think you'd agree, it is 19 millimeters. So now what do we do? Oh, okay, we're going to go find the volume of the cone, doing the same thing we did before. So the volume of the cone in this case is going to be 1/3 pi 8 squared times 19. Again, I changed the height of the cone because now the cone is the same height as the cylinder. So pulling out my handy dandy calculator, what do we get? So 64 times 19 times 1/3, or divided by 3, is this value. So the volume equals 1216 divided by 3. So the last thing that we would do, right, is because, well, that just keeps on happening. Getting rid of this. Okay, so now in order to find the total, right, I'm going to be removing the volume of the cone from the volume of the cylinder. In other words, I'm going to take this piece right here. Let's change that. What is going on there? Okay, I'm going to take this piece right here, and I'm going to subtract it, right? I'm going to subtract it from this piece right here. That was supposed to be in pi. There's a pi missing there, isn't there? Let's put that pi there. So I'm going to subtract that. okay? And I'm going to find those values. So again, I'm not going to go through the whole thing. Hopefully the idea makes sense. Just when we have composite figures, sometimes we have to add two shapes together, but sometimes, right, we have to remove stuff like in this case. Okay, that is whatever what lesson was this? This was lesson 21.3, so that was 21.3. Hopefully that gets you good. And if you have any questions, again, we will have a Zoom meeting this week towards the middle.